Let us know some common terminology regarding the mirrors, plane mirrors. Okay. So first let us see a sphere is there, right? Transparent sphere, and two mirrors, convex mirror and concave mirror, and for both the mirrors center is center of the sphere, and this center we call it as center of curvature. So center of curvature is same for concave mirror as well as convex mirror. So the first point is center of curvature. So center of curvature, the center of the curvature of the mirror is nothing but the center of the sphere of which the mirror is made. Okay. If both mirrors are made from the same sphere, the center of curvature is same. If both mirrors are made from different spheres, definitely the center of curvature will be different. So center of curvature is the center of a sphere from which the mirror is a part made. Okay. So it is just a point. Center of curvature C is just a point. So now let us see next. Now C is done. Now the next letter is P. It is the central point of the mirror. The central point of the mirror, it lies on the mirror curvature, and that we call it as a pole. So it is a geometric center of the spherical surface, and it is known as the pole. Okay. Pole is also a point. So pole and center of curvature, right? So 2 points have come. Now principal axis. Axis, you know, x-axis, y-axis. X-axis is a reference line, number line, and y-axis is also a number line, reference line. Here also principal axis. The line joining C and P, center of curvature and P, we call it as a principal axis, right? So we use this as a number line. Okay. So let us see the next point, radius of the curvature. Radius of the curvature. Very simple. It is the distance between center and any point on the sphere is known as radius of curvature. But here P lies on the curvature. Therefore, the distance between center of curvature and the point P, we call it as a radius of the curvature. It is simple mathematical terms. So total how many? 1, 2, 3, 4. Center of curvature, pole, principal axis and radius of curvature. Principal focus. So principal focus will be different for both the mirrors. Let us see concave mirror, principal focus. This is the next point, focus. Focus simply you can use, or principal focus also, both are fine. So for concave mirror, how it goes, let us see. This is the concave mirror. C is the center of curvature, P is the pole, and then principal axis, and then parallel lines. So a parallel beam of light falling on the reflecting surface of the concave mirror. So then they reflect through one point. They reflect all the rays, goes through a point, passes through a point, and that point we call it as F, and F is nothing but principal focus. So concave mirror, the reflected rays meet at a point F on the principal axis, and that point we call it as a focus of the concave mirror. Let us see convex mirror. So for that we have to draw a convex mirror. Now same procedure you have to apply. For this also center of curvature will be there, and pole will be there, and principal axis will be there, and also parallel line will be there. Here the reflecting surface is inside, and here also they are reflecting. So now we are sending the parallel rays. So they are falling on the reflecting surface. So then what happened? All those rays diverge, they appear diverge. See, they appear diverge from a point. All these things, they appears, okay, and this point we call it as a focus, okay, focus, and the definition goes like this: a reflected rays do not meet at any point, but they appear to come from a point, and that point is known as a principal focus. So it lies behind the mirror. Principal focus is behind the mirror. Mirror is this side, focus is that side. Whereas concave mirror is in front of the mirror. For convex mirror, it is focus is lying behind the mirror. I hope you have understood.